Let's look at the graph of cotangent. We know that the cotangent of theta is equal to cosine theta over sine theta. So we can use this identity and a table of sine and cosine values to sketch a graph of the cotangent function. Now, notice the theta values that we've chosen here. They're on the unit circle and they're ranging from 0 to pi. This will help us get a good idea of what one cycle of the cotangent function looks like. So let's get our unit circle ready to go here. And at 0, I know I'm at the point 1, 0. So sine is 0, cosine is 1. Now which way are we dividing? I'm dividing cosine divided by sine. So I want 1 divided by 0. Ugh, undefined. Okay. Hopefully we have better luck at the next angle. How about pi over 6? That's this angle here. So what's going on there? Well, sine is the smaller one, 1/2. Cosine is the larger one because I'm out farther than I am up. And when I do cosine divided by sine, I get root 3 over 2 divided by 1/2 gives me just root 3. So root 3 is the output when pi over 6 is the input. How about pi over 4? So pi over 4, I know that these values for sine and cosine are both root 2 over 2. So when I divide them, I get 1 for my output of cotangent, and the input is pi over 4. All right, so there's that. And what about pi over 3? Well, pi over 3, I'm over just a little bit, but up the farther amount. So the sine value is root 3 over 2, and the cosine value is 1/2. And again, cosine over sine, okay, that's going to give me 1/2 divided by root 3 over 2. Actually gives me 1 over root 3 for the output when pi over 3 is the input. Now at pi over 2, I'm going to have the sine of 1, sine is equal to 1, and the cosine of pi over 2 is equal to 0. But 0 divided by 1 is not undefined, it's just equal to 0. So when my input is pi over 2, my output is 0. Now, at 2 pi over 3, what's going on? Let's draw a new unit circle. That's this value right here. So the sine is going to still be up root 3 over 2, but now the cosine is negative 1/2. So if I have negative 1/2 divided by root 3 over 2, 2 pi over 3 is my input. Well, what is my output? Well, let's see. Negative 1/2 divided by root 3 over 2. It's really similar to 1/2 divided by root 3 over 2, but just change it by a sign. So this should be 1 over root 3. All right, what about 3 pi over 4? I can see that my sine value should be root 2 over 2, whereas the cosine will be negative root 2 over 2. And then, oops, don't need two negatives, there we go. And when I do negative root 2 over 2 divided by root 2 over 2, I just get negative 1 as my output. And then, so that was there. And then my last little piece still here in quadrant 2 at 5 pi over 6. My y coordinate there is 1/2. My x coordinate is negative 3 over 2. And then I'm dividing here. I'm going to get negative root 3 as my output. And then my input here is 5 pi over 6. And then when I'm down at pi, what's my point right at pi? I'm at negative 1, 0. So my sine value is 0. My cosine is negative 1. But if I'm doing negative 1 divided by 0, I get undefined. Okay, so I'm undefined at 0 and pi. So let's draw in a vertical asymptote, both at 0 and at pi, to reflect what I've just found. Okay. I'm also probably going to need the fact that root 3 is about, let's see, let's go over here and remember, root 3 is about 1.7. And 1 over root 3, I said, was about 0.6. Okay. So that'll help us when we're trying to kind of see where these live. And let's look at, let's just look at 5 pi over 6. I can see that right here. That's going to be put in 5 pi over 6, have an output of negative root 3 or negative 1.7. So this is about negative 1.7. That's about right here. All right, plug in 3 pi over 4. So where is that going to live? Well, think of this just in fourths. There it is. Plug in 3 pi over 4, get out negative 1. Okay. Plug in 2 pi over 3. All right, where's that? Well, think of this as in thirds. So, oops. Let's see here, thirds. This would be 1/3 of pi, 2/3 of pi. I'm just breaking it into 3 pieces. I want the 2/3 of pi. So 2 pi over 3, output negative 1 over root 3. So remember what that's going to be. It's about negative 0.6. So plug in 2 pi over 3. Output is around negative 0.6. Okay. Pi over 2, output of 0, great. Pi over 3, output is 1 over root 3. Well, we know that's about 0.6, so there. Plug in pi over 4, output of 1, here. And then plug in pi over 6, output of 1.7, oops, about right there. Okay, and then I know that input of 0 results in undefined, not in the domain. So my cotangent actually is going to look like this, and that is one complete cycle. And so my period is pi. What about the range? Well, the range is all real numbers, right? It goes up, 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 and down, 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 doesn't have any breaks. What about the domain? Well, I could draw some more cycles if I want. And it just keeps going on and on. But what happens is I just repeat the same shape. And the only problem areas are these multiples of pi, right? Everywhere else seems fine, except for at pi. So my domain I want to write as all thetas are allowed such that they meet the following condition. Well, I'm saying as long as they're not something. So as long as theta is not equal to n pi, where n is inside the set of the integers. So that just means if I'm starting at 0 and I add some number of pi's, right? My jump is pi's, I'm always going to land on something bad. So I'm saying I'm not allowed to be one of those things, but I can be any other angle. And what about even and odd? Okay, so when if I were to, it's a little tricky to see this, but if you were to rotate this piece here 180 degrees around the origin, it would actually land on this piece there. You can kind of see like this point will go to this point will go to this point, etc. So this is an odd function, and so I can see that cotan of negative theta would be negative cotan of theta. So we have a pretty good idea of what it looks like, how long the cycles are, what the domain and range are, and how we came up with that graph, right? Just using our values of sine and cosine.